Okay, so today we're going to be looking at the NodeJs async library and the built-in modules. So the NodeJs async library was created to solve the problem of managing asynchronous control flows in JavaScript applications. Then before promises and async await was introduced, the Node async library was used to solve the problem of callback hell, asynchronous control flow, and error handling. So it's provides a collection of utility functions for managing asynchronous operations. And it's widely used to perform tasks like executing functions, in parallel series and more complex patterns. And as we all know, they always update packages. So they might have updated it or added some more features, but we're going to be talking about some of its features today. And to install it, you simply give the command npm install async, and the async library will be installed. The async package provides several functions that help you manage asynchronous operations in various ways. The series that executes an array of functions in series, one after the other. Then each function in turn must call the provided callback to signal completion. Then the parallel, which executes an array of functions in parallel and waits for all of them to complete before calling the callback. The waterfall, which executes a series of functions, passing the result of each function as an argument to the next function. Then the each, which iterates over an array and applies an asynchronous function to each item, and many other functions. Error handling. Async package provides ways to handle errors also that may occur during some asynchronous operations. Then promises support. It has a utility function known as the asyncify that converts promise-based functions into callback-based functions. Then it is both compatible in browsers and NodeJs environments. And it has a wide range of communities, so that makes it interesting. So without wasting much time, I think we jump into writing code and we'll try to see how some of these methods work. So I think we'll be starting with let me create a file and name it async, a folder, then cd async and touch parallels.js. So we're going to be starting with the parallel utility function. First of all, we initialize a package or JSON file. Then we install the async package. Good. So now we can be able to use it. If you open our package.json, you can see that we have our async version 3.2. And let's change our type here to modules. I don't like working with CommonJS. So Suppose you have two tasks that can be executed in parallel. Here is how you can handle that. You can simply import async from async. Then you simply say async that you can see all the functions, all the utility functions here. Or the one we're looking for is async.parallel. Or you give it an array. Then inside this array, you write your functions in the order you want them to be executed. So first of all, we start with the first function. Then we pass it a callback function. We set timeout. It's an asynchronous function, so we set timeout. Let's log something like task 1 completed. Then we invoke our callback function. Then we pass it the first argument of error, that is null. The null means there's no error. Then we pass in result 1. That's our first function. And this set timeout is supposed to, let's say, in 1 minute, sorry, in 1.5 seconds. It should be executed in 1.5 seconds. Then we take in another function with a callback. Then we set timeout. Let us copy this, paste, then change this to 0.5 second. Then change this to task 2 and result 2. Finally, outside of the array, it's a function that will handle errors for us. In results, we handle errors and we process the final result. See, if error console.error error. But if there's no error, then we want to simply log the result. And then maybe you may like to even perform some other calculations or operations down below this code block. But then this is simply a waterfall function. And if we execute this function, you will notice that this will be called before this. Even if this will be executed in 0.5 second and this one 1.5 second, you notice that the results will be in order. So let's see how this works. As you can see, the second function is called first. Task 2 completed, task 1 completed, but the result, you can see the first function is, the result of the first function is returned first, and the result of the second function second. So you can see how helpful the async library is. Just imagine you want to do this manually. You're going to be writing some logic for the promise to wait for the second function to finish executing, then execute the first one, then return the result in order. But with the async library, you don't have to stress yourself doing all of that. And that's it. Let's look at the next UTU, which is waterfall. the waterfall util. And in the waterfall util, let's assume you have a sequence of tasks where the result of each task is passed as an argument to the next task. Like you have about 3 tasks. You want the first task to finish, then pass the result to the second task. The second task will use the result, then pass it to the third task, and in that order to the execution, the waterfall finishes its execution. So in that case, you simply use the waterfall util function. You see async.waterfall, pass in an array, and your first function. That is the initial function that we start the processing of the result. That's your first function. Then you pass in, you return your callback. The callback function you pass in as a parameter, you invoke it here with the first argument of null and second argument of a string initial value. This is your initial value and your initial function. Then you go ahead, the second function here. You pass it the previous result and a callback that you can log previous results in previous results. Then you go ahead and write some kind of logic that will show that this is actually all these functions are executed in a sequence order. Like you can say let's say updated result is equal to previous result plus, we concatenate it with something like state 2. Then you invoke your callback function, pass in a null and your updated result. Okay, so let's just copy this function and paste it down here. Just copy this function and paste, then change this one to state 3. And come down here and handle errors and the result. We handle our error. If there's any error, if no errors, we process and return our result. Is there any error? If okay, go fix up your internet. Okay. Is there any error? Yes, if there is, log it to the error console. Error. If not, then just log our final result. Okay. Let's see how this works. Initial value. Let's see. Step 1. Wow, this is sweet. Can you see this? Or we can even change this to step 1 instead of writing it, making it an initial value. We can say step 1 like this. Then we execute this again. Can you see this? Previous result, step 1. Previous result, step 1. Next, this is the step 1, followed by the step 2 here. Then final result, step 1, step 2, step 3. And you can see how in order these functions are being called, how they are being executed. And that is how the waterfall method works. And the next one we're going to be looking at is the async that the each function. I mean the each util function. Okay. I guess some of you may be wondering why. Yes. If you're using Windows, the touch command may not work. You may be seeing me do this touch file. If you're using Windows, the touch command may not work. So if you want to create a file using the command line, simply give it this command, echo. This command usually you can specify something like something. You want to echo something to your each.js file. As you can see, we have something here. We are appending the something to this file. We can easily say if you don't want to append, you want to override the content that's inside the file. You can see you make this a single arrowhead, not double arrow. You can then say each.js. As you can see, we've overwritten the file. You see we have some gibberish inside this file, and then we'll give you this command. Okay, what's happening? Then we'll give you this command. Red enemy. Okay, let's save it. We did not save the file, so the file will be overwritten with this new content. But if you want to just append it, do something like this, and then it will be appended. You do again to append, do again. You are writing content. But if you want to just create the file, you simply do something like this, which shows you are creating an empty file with no content. And you, as you can see, we appended an empty line to it. If you delete it and do it again, then you can see an empty file. But on Mac, you can simply do something, just touch the file. And your file is created. Okay. So let's see how we can work with the each utility function. You can say import async from async. Let's create an array of 7, 8. Then we want to process this array. We want to perform some like operation on each item of this array. Then we can easily say async.each. Then first thing, the array. Second, the function that will process the array. And this function will take in an item and a callback function. So you simply log processing let's say item like this. Then you put in your item. Then you invoke your callback like this. Then next is a function that will handle errors. We see error. Is there any error? Yes. Then if there are any errors, okay, we have to close this. If there are any errors, then log the error to the error console. If no errors, then log all items processed. Okay, and let's test our file. Can you see this? Pressing item 1, pressing item 2, pressing item 3, pressing item 7, 8, and so on, all items processed. You can see pressing item, this is item times 2. You can write any kind of logic in here. You can even take in this function, can be an asynchronous function that you can use to like make a network request or fetch data and process some kind of logic before ending the each function. You can see we're multiplying each item here by 2, 1 times 2, 2, 2 times 2, 4, and so on and so forth. So that's how basically how the async package is useful. That's how basically it is useful. So I think we're going to be seeing how, let's assume we've seen how basically it can work, how useful it can be. Then let's see how we can use it to handle callback, hell, asynchronous control flow, and error handling. It's all the same thing. We've the examples I've given, if you try to like implement them manually without using the async package, you may actually end up with a callback hell or mess things up and your code will be messy. So as we all know what a callback here is. Most programmers or most software engineers refer to it as pyramid of doom. They call it pyramid of doom. It occurs when you have deeply nested callbacks, yes, and it makes code harder to read and maintain also, and even to debug, because testing nested functions is not an easy task. So the async library solves this. Okay, let's try to write a simple let's give a simple example without using the async library, then try to use the async library in order to see the difference. If you want to actually write some kind of logic, a function that will read from a file, then write it to another file after converting everything from the input file to uppercase, then write it to an output file. Okay, so let's see how we can do this without the async package, then how we can do it using the async package. First of all, working with files, you need a file system, which is known as the FS. So say import FS from FS. Okay. So first of all, we want to read from the input file. So let's actually create an input file. Let's say input.txt. Then we just come here, copy everything from here, then paste it inside this file. Okay, we've got our file. So we'll come here and see fs dot no, there's a fs dot read file. It's asynchronous. Then we take in the name of the file and if a callback function with error and data. With error and data. So if there are any errors, you simply log the errors to the error console. Let's say error reading file. Then specify the error, something like that. And if there are no errors, then we simply say, let's say returned data or processed data or any kind of name you want to give it is equal to data dot to uppercase. Then after reading this data and converting it to uppercase, we want to actually write it to another file, which is the output file. And the way the write function, the write file function in FS works is if the file doesn't exist, it will create a new one, then write the content to that newly created file. So we easily say fs.write write file. Okay. So first in is the name of the file. Let's say output txt, and then second is the data we want to write to the file. So we have our returned data, and then third, it's a function that handles errors for us. A callback function that handles errors. Then we say if there are any errors during the time of writing to this file, simply say, let's copy this and paste console.error writing file. You specify the error. But if there are no errors, they will simply want to log data process success. Data processed successfully or data processed successfully. Doesn't matter. So let's come here and run our function. Let's see what happens. Test. Okay. Data dot to uppercase. This is not a function. Okay. First of all, let's see what's being returned. Okay, it's a buffer. This is a buffer being returned. To string. That's to uppercase. What is returning is it's a binary data. So you have to convert it to a string before converting it to uppercase. I think that's why we're getting an error. And let's see what our input file contains. You can see our output file is created, but then we had an error. It is created with the content, but the content is not converted to uppercase. All these alphabetical words, they are not converted to uppercase because what this is actually returning, it's a buffer. There's the binary data. So it did not convert anything. Let's see what the first line contains. IMP. So I think if you check the ASCII characters, you notice that in binary form, in decimal form, I is 69, M is 6D or something like that. We'll come to that later. But in this, what is returning here is actually a binary. Let's see how it works now. So we got our data and now it's working correctly. The reason why was because it was returning a buffer and we did not convert it to, now if you open your output.txt, is that everything is converted to uppercase. Now it works as expected. So let's remove this console here and then run it again. Data process success. So if you open your output.txt file, you see that everything is converted to uppercase. Okay, so now let's try to use the async package to do this without nesting this second write function. Let's try to use the async package to do that. Good. Someone just confirmed that I is 69. Yes. So it's returning. Okay. So we import our async. Import async from not async, but async. Then we'll come down here and we'll see. Instead of writing this manually and nesting our functions, we don't have to do that. We just say async at waterfall. Then we first of all create an array. Then we pass in our read function. Read file. This read file will take our input file. Let's do away with this output file first. To take our input file, then not our input file really. Take a callback. It's a callback because when we specify the read function, the fs read function, then it will take the input file. So let's specify our callback. Then we simply say fs read file, read file asynchronously. Then we specify our input file. Then okay, so we made a mistake here. If really we don't want to convert it to a string, then we specify the encoding format. The format we want this, is it UTF-8, UTF-16, or base 64, or something like that. So that was actually the mistake we made. I just came to remember that specify UTF-8. So you should actually read the file and output it in UTF-8 format. Then specify our callback function with error and data. So if there are any errors, then do this thing like this. If there are any errors, but if there are no errors, then we simply call back and then pass in no errors, then our data. Or we can even pass in a callback here because we later use this function. Pass in a callback, our callback, and then our first parameter is the error. So pass it and we'll forget about the second one, which is the data. And then we'll come to the next function, which we process the data. Function process data. Then we pass in the data, then the callback. Then inside this, we see const processed data or return data is equal to data dot uppercase like this. Now we've specified our encoding this thing format here, so we don't need to convert it to string before to uppercase. We directly convert it to an uppercase. Then the next thing is we want to really call back, invoke our callback and pass in the data. So invoke our callback, and let's remember that the first argument is error, and then the second argument is the data, which is our processed data. Okay, processed like this, yes, processed data. Then our next function is a function that after processing the data, it will write. Remember how the waterfall util function works? This will be done in sequence. This will first of all read the data, then pass the data to this function. This function will process the data. Then after processing it, it will pass it to the next function that will write the data to the output file, which is write data with processed data as a parameter. Then a callback function. Then we'll do something like fs write file. The first argument is our output file. Second argument is our processed data. The data we want to write to the file. And then a callback function with error. Callback function with error. So if there are any errors, we'll simply call back, invoke our callback function and pass the errors to the function. If there are no errors, we invoke our callback and pass in null. This is just for error handling sake, because already we've written, if there are no errors, we call back, we invoke our callback function and pass in null, because we're not actually returning any data. We are writing the data to this output file. So we pass in null here, and our data will be written to our output file with no errors and no problems. But if there are errors, we pass this error to the callback function, and then it will take care of the errors for us. So this is the callback function that will handle the errors for us. Is there any errors? Log it to the error console. Error, error. But if there are no errors, what should we do? Should we buy something? No, say else. What do we want to do? We'll simply log, let's say something like data processed and written successfully, something like this. Okay. So let's see if this works. Okay, it works. So let's see our output file. And it's working. It's still the same thing as when we did not use the async library. But you can clearly see the difference here. Here the code is much short. We have about 13 lines of code here, or probably 13, 14 lines of code. But coming to display, we have a whole bunch of code. But that is not the problem. If your code is minimal, it also works as expected. I know that testing is very, very important. And you need to test your file or your functions, and you need to have control over your functions also. So while testing this file, you have to also handle the nested function here while testing this function. And if you want to test the nested function, you have everything to do with the enclosing function, which sometimes can be very stressful. But when it comes here, you test this read file separately. You come here, you test the process data separately. You come to the write data and you process the function separately. And the most interesting thing here is this file does its work, like it does its work separately and then pass the data. It returns the data and pass it to this function. This function processes it and then passes it to this function again. This function processes it, and then the last one is the error function. If there are no errors, then it's logged to the console that data processed are written successfully. So that's this interesting, and we've almost used an hour to talk about the async library. And the fun part here is built-in modules. So as you can see, we don't need to talk about the asynchronous control flow or the error handling because everything is here. We've discussed everything. The asynchronous control flow, see how we are controlling the flow of this. We even tested it here, how we can control the flow. The parallel, how we can control the flow, first function, second function, and all of that without callback hell. Just keeping your functions in an array. And that is sweet. That's awesome. We came here and we give a more interesting example. We did this without the async library. Then we use the async library to simplify things. And that is good. We're not really going to testing vanilla JavaScript in this course, but later we'll be testing Express apps. So you get accustomed to testing. But I'll advise you, maybe you don't really need that, but you can go back and then check out how you can test vanilla JavaScript, test functions, test files, and all of that you write your own tests, or you use libraries like Jest or other libraries that will simplify things for you. And without talking much, let's jump into inbuilt node modules. What should I say? Okay. Built-in modules, right? Okay. So let's just make this the name of built-in modules. And then after making it, we also cd into built-in modules. That's good. And we are in. So the first item on our list, we all know what built-in modules are. They are actually functions provided by NodeJs, so we don't have to go about writing our own functions that does all of this and all of that. The NodeJs FS module is a built-in module that provides an interface for interacting with the file system in a Node.js environment. It simply stands for file system, FS, F for file and S for system. And it allows you to perform various operations on files and directories, such as reading, writing, updating, deleting, and manipulating the FS. The files in your project or whatsoever. So the FS module provide both synchronous and asynchronous methods for system operations. So we're not going to be talking much, but in reading files, we have the FS or read file, or if you want to read the file synchronously, you can say FS or read file sync. Then let's try to look at the blueprint of these functions before we can work with them. Let's see, touch fs.js. Where is it? Okay. Where is our built-in? Okay, fs. So the fs or read file, you simply pass in fs.read file. Then you pass in the path of the file, and then options, and then a callback. A callback for handling errors. But when it comes to the read file sync, what's this? The read file sync. This is done synchronously, not asynchronously, so you don't need the callback. You don't need, no errors will occur during the reading of file. If there are any errors, maybe the file doesn't exist or something like that, so your code will actually break. So, but when reading it asynchronously, that is an asynchronous operator. So any error can occur at any time. So you need to handle errors, and then need to know where those errors are happening and where they are really occurring. Something like that. And then we have the write file. The write file takes in a file, the data options, and callback. If you have, let's say the write file, path, data, options, and a callback. The data to be written to the file. And the write file sync doesn't need a callback as well. The write, this is write file sync. This doesn't need a callback, but it needs data to be written to the file. Then appending files, you have append file, we have make directory, read directory, rename files, rename sync, unlink. That is unlink is deleting. Then we have start. Okay, without talking much, I think we have to jump into writing code. We don't have much, a lot of time. Let's say we have a file txt. Then we just come down here, we copy this, then we bring it down to our file txt. Okay, now we say import fs from fs. So what do we actually want to do? We want to read the file fs read file. We want to read it asynchronously. So say file.txt, then the encoding, which is UTF-8. Then we have error data. And if there are errors, just log the errors on the console. If there are no errors, what do you want to do? You want to say log sorry about that. My network got messed up. Okay. So I had some network issues. Just be patient with me. I'll be back in a few seconds. Okay, sorry about that. So we're back. And now we can actually read the contents of our file. So we can, let's test it out and see. Okay, we're having an error, import fs from fs. Okay. So I did not initialize a package.json file. And here it is. And here is our content. So it is working as expected. So this is how to basically use the read file. And you can also use other methods like rename. Let's say we want to rename our file. Can do something like fs rename, and the old file name is file txt. I want to rename it to readme.md. And we want to do it synchronously. So we say rename async. We don't want to add any callback function. So we run our file. And you can see our file name is changed to readme.md and not file.txt. And see our readme.md is active. We can actually delete the file or get the, let's get this, let's say we're going to get the statistics of this file. fa.start sync, the readme file. let's say result is equal to, then we log the result. This is the statistics of our file. The dev, the mode, the UID, the GID, block size, the size blocks, the created time, modified time, bet time in milliseconds, created time, modified time. Okay, so we actually created the file that doesn't matter. We just need to see the statistics of the file and how the stats method work, and we can actually unlink this file fs unlink sync readme.md, and if you run our file now, the readme is deleted. We actually deleted it. So that is actually the file system. The file system has so many methods, and you can see you have fs, and if you do something like that, you have the read file, write file sync, read directly sync. Okay, let's say we want to read our current directory. We can do something like fs or read directly sync. We want to read it synchronously, not asynchronously. So we'll just do something like the path. Path is our current directory, and then UTF-8. Okay. Like this, UTF-8. And what we have in this current directory, we only have the package.json and the fs file. So we can actually, this is returning an array, and you can do something like, let's say, const result is equal to fs or read file, read directly sync. You see, for const file in result, say log file, something like this. Oh, this we're iterating over the results. Oh. What are we returning here? This is an array. Oh, file off. In is for object and off is for arrays. I made a mistake. We have our fs.js and package.json. Okay, let's move on to another built-in module. I think we've discussed about the file system, and with the given examples, you can be able to use it and then try to figure out other methods on your own and by yourself. So we have the NodeJs HTTP/HTTPS module. The HTTP and HTTPS module are built-in modules that provide an interface for creating and interacting with HTTP and HTTPS servers, respectively. These modules allow you to build server applications that can handle incoming HTTP requests. Then it can serve responses and then manage communication with clients. So the HTTP it stands for a hypertext transfer protocol, and then the HTTPS stands for hypertext transfer protocol secure. So the HTTP is secure and the HTTP is not secure. Okay, so let's see how we can actually make things up with the HTTP. Sorry. In working with the HTTP module, first of all, work with the HTTP, then we try to understand the HTTPS. So you say import HTTP from HTTP. Then you say const server, our server is equals to HTTP dot create server. This is what it basically does. To create a server, and then this server will take a function, and you can simply do something like, you can write your function outside here, pass it a request and a response. And then you see, can give it a name of handler that will handle the request and responses. Then you can say response dot write head with a status code of 200, which means okay, our request is successful and that's returned successfully, with a content type of a content type. What you actually want to return is a text, normal text, no HTML or any kind of data. So we say text / plain, so that our app, our browser will know the kind of data returned and will be able to handle it successfully. Then we will send the data we want to send. .end. Hello, HTTP. Send it something like this. And then in our create server, we simply say handler, pass in our handler. Then we come here and say server.listing. You see port 3000. I can give it a host name. If you don't want to give it a host name, you can actually ignore this. And you can actually ignore the port as well. They are optional. That's why you can see this question mark here, another question mark here. They are actually optional. And the backlog is also optional. The callback function is also optional. You can leave everything optional, but it's advisable to pass in a port and then a callback function. Modules. Then you see call HTTP / localhost 3000. I can see what is returned. You can actually, we don't want this. And this is forbidden in C and other programming languages also. So let's follow it here. You have hello HTTP. This is what is returned from our server, actually. So as we can see, our server is working, and that is how the HTTP module work to create interactive web servers. And let's say, for instance, we want to use the HTTPS. Yeah, Moses, you can go ahead.
Okay, I want to ask like some input you normally type in the terminal. Can you always tell us the meaning? Sometimes we don't know the meaning.
Okay,
Like,
this, some things are, okay, I will try to brief you on some things, but they're way outside of what you're trying to teach, but actually this is simply trying to make a request to this URL, like do something like something like this. It is specific to the web terminal. You are trying to make a request to this. Let's assume our server is running on port 3000, and you make a request. You are making a request to this URL. Let's assume this is a URL from a separate web server. So you are making a request to this URL. I know, and it is a GET request. So when you make a request to this URL, it is expected to return this hello HTTP, and it's a text file. So when you make this request, this is what it will return to you, hello HTTP, because you've implemented it and you want it to send this. When the request is made to this, you want the response to be this. So we made the request to this server, and the server sends us a response of this. And now testing this on the terminal, this is how we do it. But if you want to test it in a browser, you can actually open your browser and go to localhost 3000,
Okay.
and then you see the request there.
The one I know is the browser one, so I'm surprised seeing this. That's why I asked.
Okay,
And
this
and
malloc.
for the what does the call keyword mean?
Simply making a request.
Okay, is it only for Windows or?
Yeah, you can
Uh,
use it on Windows, on Mac.
okay, okay.
Yes.
Thank you, sir.
Mm, okay. Thank you, Moses, for asking. And that was brief. But then concerning the core keyword, we're talking much about it later, but not here. Now let's
Okay, sir.
try to understand HTTPS. HTTPS is tricky, and this is where we understand how secured requests are being made on the internet. So let's assume we want to use the HTTPS. We also need the FS module. The FS, import FS from FS like this, and then we'll come down here. First of all, we need options. We say const options. And you may be wondering what these options are and what they stand for. And then we need a key and a certificate. And let me write this code, then we'll go ahead and explain what we need the key for and what we need the certificate for. Then we have a file. Let's say a file. We have key. We say fs.read file sync, where we provide, let's say pk.pm, and then we provide the certificate of fs.read file sync. Then the public certificate, say psat dot, and then we've had our options. So when we want to create our server, we do something like https dot create server, but now we need our options before the handler. We need our options and the handler. Then we are using a secured port. Then we say server then we use a secured port like 443. All these, the ports kind of a thing and the local host kind of has to do with networking. So maybe you take a look at SSL and TTL and all of that to understand networking and how the computer communicates on the web or using network requests. So this, we're not going to be practicalizing this because we've written the code, but we don't actually have a certificate and a private key. And now you may be asking, why do we need a private key? You know, if you want to send a message to me, and you don't envelope that message, it's actually, the messenger may actually open that message on his way to my place and then see the content of the message. And that is not what you want. So let's talk about the private key and the public certificate. The private key and the public certificate are both essential components of secure communication protocol, such as HTTPS. They are used to establish secure connection between clients, like the web browsers and the servers. So the private key, let's look at the private key before the public certificate. These are very important. We need to understand this in order to, like, let's assume you are the tech lead, or now you are the head of the company that is dealing with all this, and you have confidential information, like confidential data, customized data, and don't want it exposed, or you want to implement a web server, and let's say you are working with Engine X and you are a member of the core team, and you have to implement all those things. You need to understand all of this. If not, that won't be possible. That is where we say software engineering is not all about coding, but it's all about problem solving. You need to understand all of these things. We have senior software engineers, senior developers that build applications without even knowing what a public key is, what a certificate is. But they're building it because, you know, their work is simple and they're not really where those kind of services are needed. But it's advisable to know this as a software engineer. You need to know all of this so that anywhere you find yourself, you fit in. So the private key is a critical component of asymmetric encryption. We have symmetric and asymmetric. And asymmetric encryption has to do with two keys, while symmetric has to do with a single key that we both encrypt and decrypt. But that is outside of this lesson. So let's focus on what we're talking about. And then, this is the foundation of secure communication on the internet. The private key is kept secret and only known to the server. The private key is kept secret and it's only known to the server. So the private key is used for two primary purposes: encryption and digital signatures. Encryption and digital signatures. So for encryption, when the server needs to send confidential information to the client, what it does, it encrypts the data using the client's public key. You know, when a client sends a request to the server, it sends a public key. So what the server does, it encrypts the data that is sent back to the client with the client's public key, that the key that the client sent. So the client can then decrypt the data using its corresponding private key. You know, the client's public key, it's aware of how the private key works. So any data it encrypts, the private key knows how the public key encrypts data so that it can be able to decrypt it. So when the client sends a public key to the server uses its private key to encrypt data, then send it back. It used the client's public key to encrypt the data and then send it back to the client. So when the data arrives to the client will use its own private key to decrypt the data. So that is encryption, and that's how it works. So the private key is also used to generate digital signatures. These signatures are attached to the data, ensure that the data has not been tampered with during transmission. So the recipient can verify the digital signature using the server's public key. Now, what is happening here is, when the server receives the public key from the client, it uses it to encrypt the data. And after encrypting that data, it attach a public, a digital signature to it. After encrypting the data with the server's, the client's public key, it will attach a digital signature to that request, so that when the data arrives, the client will be able to know that, yes, this data has not been tampered with during the transmission. And the recipient can verify. The server will also send along its public key to the client. It cannot send its private key because anything can happen along the way. And if the private key is tampered with, that's all. Everything will be gone. The hacker can hack in and take everything. But if it sends its public key, even if it's tampered with, when the data arrives to the client will validate the data and discover, oh, the data has been tampered with. Then it will send a request back to the server, indicating that this data you sent to me, that you transmitted with your public key and my own public key with the encrypted data, this data has been tampered with. So modify this data and send another copy of this data to me that has not been tampered so I can process it. That's how digital signatures and encryption works. So coming to the public certificate. The public certificate contains the server's public key. And it distributes to clients like let's say web browsers as part of the SSL and TLS handshake process. The certificate is issued by a trusted certificate authority known as the CA and serves two main purposes. The public certificate serves two main purposes: authentication and key exchange. Authentication and key exchange. The private key serves two: encryption and digital signatures. The public key serves also two: authentication and key exchange. When a client connects to a server, the server sends its public certificate. Can you hear that? The server sends its public certificate. The client uses this certificate to verify the server's authenticity. This process helps prevent some kind of middleman attacks, like it's called man in the middle attacks, by ensuring that the client is connecting to the intended server. Because you can actually get access to this transmitted data and then modify it and redirect it to another server, which is not what you want. So once you've tampered with this transmission, when it arrives to the client will know this has been tampered with. So we don't have to do anything. Let us send a request back to the server to tell the server that this has been tampered with. So it will send out a fresh copy of this information. So the next is key exchange. The public certificate contains the server's public key. The public certificate contains the server's public key, which is sent together with the data that is being encrypted and sent to the client. Then, which the client uses to encrypt data that is want to send to the server securely. Only the server's private key can decrypt this data. This is a bidirectional communication stuff. When a client wants to send a request to the server, it actually sends its public key with a request. So the server now will take the public key, use its private key to encrypt the data together with the client's public key, then send some digital signatures attached with the server's public key as well. So when the transmissions arrive, when the transmission is being processed, like when the data arrives to the client will decrypt the data with the server's public key and then read the data, process it, and then send back the request. Without the server's public key, the client cannot encrypt data, because if it encrypts data using its own private key, the server cannot understand its own private key. That's the reason why it has to use the server's public key to encrypt this data so that the server's private key can be able to decrypt the data. Same as the client. The server needs to use the client's public key to encrypt data so that the client will be able to use its private key to decrypt the data. And in the same way, the server has to send its public key and some digital signatures, the public key that the client will use to encrypt the data when sending a subsequent request. I think we've spoken enough grammar already. Maybe if you don't understand, you can ask questions, but that is how the HTTPS. Yes, Moses, go ahead.
Okay, my own suggestion is that can you make a pictorial, like something pictorial to explain it?
Yeah, but maybe I will do that and send it on the Discord channel because I can't just jump out of the meeting and then do that right now.
Okay, okay.
Yeah.
Thank you.
Okay. Yeah. So that is just basically how the HTTPS works with certificates and keys. So next we'll move to the path built-in module. The path. So the Node.js part is a built-in module that provides utilities for working with file and directories. I mean, directly path in a platform independent manner. What it does, it helps construct and manipulate file paths, making your code more portable and cleaner across different operating systems. The code is even resilient across different operating systems. So we're going to be looking at some of the paths function like join, resolve, base name, directory name, extension name, normalize. But we won't be covering all of them. At least we'll give like 2, 3 examples, and then we'll move to the next built-in module. So let's assume we have a path, import paths from path. Then we have const full path or complete path is equal to path dot join. Join, let's see the outer directory, my directory, and then my file, which is the file.txt, I mean. Then we log the full paths, log full paths. That's just, as you can see. What this does, it will take all of these, the 2 directories and the file, then it will impute a slash in between them. So this becomes a directory. Or you can do something like path.join directory name with the file.txt. Oops, error. Then it's not different AS module scope. The file is being treated. So, okay. In JS file extension. Treat as command use CJS file extension. Okay. And we're getting an error here. The directory name is not defined in ES module. Okay. Okay, it's actually a server thing. So we're getting an error. It will require but and as you can see, we've gotten our full directory with our file. So we don't need to know where our file is. We just read it and get to where our file is. We read our full directory name and then attach our file to it. As you can see from users, the user, my name, the desktop project, KodeCamp, built-in module, then the file. So this is how handful paths are. We don't need to, do any kind of this thing. I'm going to see parts that resolve. Sorry, I'm doing this part that resolve. Then we can pass in F directory, then an S directory, something like that. Then we have those F directory, and all of that. The path of resolve is an absolute path by sequentially navigating through the provided path segment and returning the absolute path. This the join that they look somehow similar and work similar, but they are different. The join joins one or more path segment into a single normalized path using the appropriate platform specific separator. All these platforms have different separators. The Mac, the Windows, and the Linux, and all of that. So it uses the platform separator. You don't have to worry about that. It is taken care of automatically. Why they resolve an absolute path by sequentially navigating through the provided segments and returning an absolute path. Then the base name. You can actually see path.base name. Base name of this slash. Something like this. And the base name is simply the file.txt. No matter what you specify, no matter how many directories, the base name is the last file, the file you are pointing to. And you can see it's only returning the file. Return the base name, but take out the extension, take out the txt, and simply returning only the file. The name of the file is file. You can change this to some output let's say output.txt, and we see our output without the file extension. Okay. So that's basically how the base name works. And we have the directory name. When working with the directory name, we do something like this. Okay. Directory name. Directory name. And then we take away the extension. Then we log it to the console. And we have our directory, but without the file. Now we are pointing to the directory, which is the first directory, second directory without the file. Simply returns only the directory without the file. And this is useful when building complex applications that has to do with file handling or building servers. Servers has to do with files, where even databases and all of that has to do with files, writing and reading files, and everything. A file where someone uploads a document, a kind of a picture or a photo, anything like that. You have to keep them safe, and you have to manipulate all those resources using all these built-in modules to make things simpler. So we also have path.parse, we have normalize, we have other things that you can go make some research on them, get to use them. At this point, let's move over to the stream module. And for the stream, we're going to touch it briefly because streams.js, because in our next class, we'll be going in depth on streams and event emitters. So in this lesson, we're just going to touch them briefly. So the NodeJs stream module is a core module that provides an interface for working with streams, which are objects used for reading from or writing to sequences of data. Data of like large amounts. You cannot just read data of large amounts using the FS, the read file. You need to read them in chunks, something like that. You read them bit by bit. So in a more memory efficient and asynchronous manner, you have to use your streams to read data. Streams are a fundamental concept in Node.js and are used for a wide range of input and output operations, such as reading files, processing network data, and more. So in streams, we have readable streams, we have writable streams, and then we have duplex streams. We also have transform streams. The readable streams allow you to read data from a source, such as a file or a network socket. They emit data data events as chunks of data become available. Anytime a chunk of data comes in, it will emit it. Anytime a chunk of data comes in, to emit it, instead of waiting for the whole data to be read before being emitted or being written. And end events, when the stream has no more data to provide, then it will simply end. You call the event to end it when the stream has no data to provide. Common methods and events associated with readable streams. We have readable.on, on the data, the end, the pause, the resume, and so on. The writable streams allow you to write data to the destination, such as file or network sockets. The writable.write, writable.end, and writable.finish, on error. The duplex streams combine both readable and writable functionalities. That's why they're known as the duplex streams. They allow for bidirectional communication by implementing both the readable and writable interfaces. They can handle both writable and readable streams. Then we have the transform streams. A type of duplex stream that can modify or transform the data as it passes through. You can use them in tasks like data compression or encryption, something like that. So let's jump into examples with let's give a single example with a stream. You know, the stream has to do with I changed this to CommonJS, so let's just continue with CommonJS. Is equal to require fs. Streams has to do with reading and writing data, and you know, reading and writing data in NodeJS has to do with the file system. So everything is attached to the file system. So say const readable stream is equal to fs.create readable stream. Then we take in the input file. Let's say the input file we have file.txt. Then we create that here. Okay. Okay. I'm looking for a way to create a lorem. It's actually working here. All right. Then we can copy this. Then we can come here. Paste. Then we can copy again. Then paste. And we have about how many lines? This multiplied by 1, 2, 3, 4, 5. About 500 and something lines, more than, or getting to 1,000, or it should be more than. Something like that. But we have enough data to work on in our file. Then what we want to do is, let's create a writable stream. Because writable stream is equal to fs.create writable stream. Then we see output.txt. And then what we want to do is, we want to listen to data. What we say is readable streams dot, we're not piping, we want just the data. Okay, you can see all the options have been listed. That takes in a chunk as a parameter to the callback function. Takes in the chunk as a parameter to the callback function. And then what we want to do is, we want to log read chunk. And then we want to simply log the chunk to the console so we can see what we've got. And then we want to write the chunk to the output file. And we say writable string dot write, and we want to actually write the chunk to this file because we've specified the output file already. We want to write the chunk to the file. And then the next thing we want to specify, if there's no more data, what do we want? Readable string dot on end. What do you want to do? We need a callback here. Then we'll say we notify that let's say finished writing data, and then we'll say the writable string. We want to terminate the writable string dot end so that it will stop expecting data. The data has finished, so we want to end it so that we don't expect any data. Then we'll terminate the read stream also, the readable string dot on finish. I think the finish. Oh, it's the writable string, not the readable string. Writable string. So if the writable stream is complete, then finish. We want to be notified. So we're taking the callback function. And this callback function will simply say write operation. Let's say finished writing. And this here should be finished reading, not writing data. Finished reading. So basically what's happening here is we have an input file and an output file. They want to read data from this input file and then write it to the output file. Then we want to do it chunk by chunk, not all at once for the efficiency of the memory. So all we need to do is we read this data chunk by chunk and then we write it to this output file. Then when there's no data, the readable stream will stop and then we log finished reading on the console. And then it will also trigger the writable stream on finish. The writable stream will notify us, yes, the data has finished and there's no more data to write. So let's test this out. Can you see this? We have a buffer. A buffer is simply an array in memory that holds binary data. We talk about buffer, working with buffers. We'll talk about that later. You can see we have a buffer here. Then we have 49,000 more bytes. It's reading in chunks, red chunk. This, and we have our terminal is not that. We have red chunk. We have a buffer here. This buffer reads this. Another chunk will come in, it will read another chunk. Another chunk will come in to read the chunk. It will read data in chunks. And then after that, we have finished reading and then finished writing. And then our output file, we can see our data inside. This is our data in our output file. Okay. Later on, we can see how efficient streams are compared to normal static data writing and reading. And this is how web servers work. You don't implement web servers with just AFS or read or AFS or write. They use streams so that streams can handle large amount of data without breaking your application. So basically, that's all we can say about streams. And let's move over to event emitter. think that's what we have next on the list. Event module, yes, the event module. Okay. Event. So this is event.js. So the event module that provides a basic implementation of the event emitter pattern. The event emitter class is a class in the module that allows you to create custom objects that emit events and can have listeners to attach to them. The pattern is often used in NodeJs to handle asynchronous operations and the kind of communication between different parts of an application. This is actually a class, an object. So in creating event, let's jump into an example and see how event emitters work. So you simply require an event, you say cost event emitter is equal to require events. Is it events? Yes, it's events. Events. I don't think it's events. Let's see if we get an error. Events. Well, not autocomplete. We'll test it out and see if it's correct spelling. Then we'll create an event instance. Const event is equal to new event emitter. It's actually an object. They want to emit events. They will say event dot emit. You say event name, let's say KodeCamp event, and then say some data in the event, something like this. Then we want to listen to events. We want to say event dot on. Then you see which event are we listening to? Say KodeCamp. This is the event we want to listen to, the KodeCamp event. Then we say we take in the event. Okay, let's say the EVE as a parameter to the callback function. And then we log this to console. You see events, basically events emitted. And then we see EVE. Okay, so let's test this out and see if it actually works or if you're getting an error. Okay, no event, yes. I'm having nothing in the console. Okay, let's say, I'm not emitting the event. Let's say EV dot once. See, one time. Call back. Log once. And let's see if actually even though anything. Have I forgotten how this API works? But I didn't think it should actually work in the console unless we have to emit events. How does this work? How does this work? Basically, this is the API for event emitters, the event in Node.js. I think it's a kind of, it doesn't just work on the console like that. It's a kind of logic kind of pass through. But not to worry about that. In our next class, we're going in depth on streams and events. So we break that down and then implement everything. For now, let's keep it this way. This is just a minimal API for you create. This is an event. You want this event to emit the KodeCamp, and the data is some data in the event. The event, if you want to emit this, then we have the KodeCamp. This is the name of the event. It must be the same with the name you specify there, the KodeCamp. Then once you event, this event will take in this data as the parameter to this callback function. Sorry, as an argument to this callback function, then it will log event emitted with the data, some data in the event. And then this event will be emitted once. This one will be emitted once, only once. Even if you continue calling this will only emit once. Okay, so what next do we have on our list? We have the YouTube module, and then the crypto, the child. Let's see this touch the ones we can. Let's actually touch the YouTube. Then this YouTube module, YouTube.js. What does the YouTube module do? Actually, the YouTube module it's a module in Node.js that provides various utility functions that can be helpful in working with JavaScript objects, functions, and other common programming tasks. It is designed to provide additional functionality and convenience beyond what is available in the core JavaScript language, like util.promisify. What this actually does, it converts a callback based function into a promise based function. Then you do the formats. Let's give these two examples and move to the next one. At least let's touch two because we don't have time. Because util is equal to require util. Okay, so in this, then we have our fs. Const fs is equal to require fs. And I believe this is actually an intermediate class, but have this in mind that Node.js it's JavaScript on the server. So know what to do in Node.js and what to do on the client. So there are some methods that you apply on the server, you get an error. That was the reason why when I was trying to read the path built-in module using the ES module, it threw an error that's actually is it does not support ESM. It's only CommonJS because actually a server-only API. It's not used on the client. So it doesn't support ESM, but only CommonJS. So you should know what to do on the server and on the client. There are some APIs that are not supported on the server, but only on the client. There are some that are supported only on the client, like the document object model and the browser object model. Like the window.set timeout, Windows set timeout, and the console log. Those are specific to the browser. The set timeout and the log on the Node.js is different from the one on the browser. You cannot say window set timeout or window playtime or something like that. You can't use those on the server. So let's see how the util module works. Let's see const file promise is equal to util.promisify fs.read file, fs.read file. The promise file is taking the fs.read file as a parameter. And then let's use our function file promise dot no. It's a function that takes in, let's give it this our file here, file.txt. Then the encoding of UTF-8. No, UTF-8. And then it's actually a promise.then. This is where we handle our data log data. Then, is there any errors? Let's handle our errors. Have error log error, something like this. Yes. And then let's run our function. NodeJs. As you can see, we have our file read successfully. So this converts this to a promise. If you don't want to do something like fs.read, something like fs.read file, then you pass in a callback. Then if error, handle error, or console.log, then you just go about it like this. Convert it to a promise instead of actually convert it to a promise instead of a callback function, using the callback function in your fs or read file. And that is basically the first example. Let's look at the second example, which is fs format. Then you see custom formatted is equal to util. It's util.format, not fs. Sorry about that. Util.format. Then you see hi. Want a string? You see KodeCamp. Then you log formatted on the console. You can see, so we have hi KodeCamp. Why? Because KodeCamp is a string. Most of us don't know. I believe most of us, this works like our console function. I believe we don't know that, JavaScript is dynamically typed, or if you're working with C, in C, if you don't specify things like this, your code will break and you have no results. And if you change this to a digit, let's say an integer, and you run your code, this is not a number. You are getting not a number. Why? Because this is not a number. Then you can say, if you are changing, you can say 10, hi 10. Then you have 6, hi 10. Okay, let's comment this out and let me show you one more thing. We actually don't know that our log function can also do something like this. If you want to be strict, you can say something like the answer is specify an integer, then you pass in 10. The answer is 10. Then try to change this to a string. Sorry, it's still working. Why is it working? It's not actually okay. Wait. It means it can actually work. You see. The answer is Chris. And let me change this to a digit. No. Because JavaScript will convert a number to a string and then output it. That's the reason why we're still getting the answer is 10 here. Convert the 10 to a string and then output it. But when you change this to a string, the string cannot be converted to a number. So the answer is, we're actually expecting a number, but we got a string. So a string is not a number. That's why we're getting not a number here. So this, if you want to be strict, you'll be strict, and that's how it works. Okay. I think let's move over to one more and we'll be done for today. Which one is the next? The crypto module. Oh, the crypto module. This one is important and sweet. Crypto.js. You see const crypto is equal to require crypto. So what exactly is the crypto module and what's function? The crypto module is actually a built-in module that provides cryptographic functionality. that including like various hash functions, encryption and decryption algorithms. It allows you to work with cryptographic operations to enhance security in your own applications. And let's talk about hashing functions that is used for generating hash password. If you don't want to use packages like bcrypt, argon2, or this other one, forgotten its name, but we have numerous packages for use for that. The most popular one is bcrypt, which is efficient and not time consuming. It doesn't waste computer memory. It doesn't waste resources. That's how I love to make things easier. Then the argon2. Argon2 is also cool. But if you don't want to use any of those packages, you can simply use your inbuilt crypto. You can see const name is equal to KodeCamp. Then you want to encrypt this. Say const hash, or say name hash is equal to crypto dot what? No, crypto dot create hash. It's no hash, create hash. Then you want to use the SHA 256 algorithm. SHA of the 256 algorithm. They want to update the data, that is encrypt this data, which is the name, and then digest it, convert it to a hexadecimal. Digest, not hex. You can actually make it a binary, hexadecimal, or base 64. Okay, let's try binary and see what happens. Then let's log our name hash. Okay. Node crypto. Yes. Whoa. And this not sweet. This is not sweet. Let's change it back to hexadecimal and then try to see what it outputs. And this one is sweet. You've actually encrypted code. What you are seeing here is actually KodeCamp. But how on earth would you don't even know what's here? You don't know. You don't know at all. You don't know what's here. Okay, so this is just how to encrypt. And then let's see how we can encrypt data with keys, then decrypt them with keys. This is actually practicalizing how the server encrypts data sent to the client and all of that. So let's see how we can do this. We can actually say const algorithm is equal to, let's say random. Okay, there's this. Okay, let's say we're going to be using a 256. So I'll say A is 256 and CBC, or any random variable you can give, or just for identification, get const key is equal to crypto at random bytes 32. Const is equal to crypto at random bytes 16. Then what we want to do is const cipher is equal to crypto dot create cipher IV, the algorithm, the key, and the IV. You have the algorithm, the key, and IV, like this. Then what you say, const encrypted is equal to cipher dot updates, no, update What do we want to update? We want to update the sensitive, okay, let's say sensitive data, comma, UTF-8, comma, then in hexadecimal form, plus cipher dot final hexadecimal. This is just encryption. You are just encrypting this in such a way it will take you time. You cannot just even decrypt it. You used to use some hardcore algorithms. If you want to log encrypted data, so actually log this to the console. And this is our encrypted data. Can you see? There's nothing you can understand here. Nothing to understand. Okay, let's change the sensitive data to something like KodeCamp. And then we want to decrypt, we want to decipher our data, also known as, we want to decrypt it. We have encrypted it. Then we want to decipher it. Because decipher is equal to crypto. Crypto.create decipher IV of algorithm, the key, and the IV we give. And then we say decrypted is now equal to cipher dot updates. Update encrypted. The data we encrypted, we want to decrypt it. Hexadecimal form. Then UTF-8. And we want to log decipher, not cipher. This is decipher, yeah? And let's log our decrypted data on the console. No. Decrypted. Okay. No. Any problems? Okay. Cipher IV X UTF-8. Then okay, plus we actually messed up things. Plus decipher dot final and then hex. You can see how to decrypt these things. Okay. Error. Please open with case text. You encourage yourself NodeJs internals. Where are we getting this error? Can you change a coding? Oh. It's like I made a mistake here. It goes by either your blog in NodeJs or inquiries of NodeJs internals. Please open an issue. Can you change encoding? Did you change any encoding here? X UTF-8. Oh, this is supposed to be changed. Below, we have UTF-8. X. Let's see how this. It's fine now. Bad decrypt. Oh. We're out of time. So that's basically how it works. We are supposed to decrypt this, but we're getting an error. Bad decrypt. And I will resolve this error and then send the result to you on the Discord channel. I think that's all for today. And any questions? To show you how strict this is, any little mistake and you cannot decrypt your data. Any single mistake and you cannot decrypt your data. I think we've made a kind of mistake here. That's the reason why we can't possibly decrypt our data. Okay, so in absence of any question, let's call it a day and we'll see on Thursday. Thank you all.